to talk on logarithmic differentiation. That is when we are dealing with log differentiation, when we are given a function and it is in form of log, that is in form of natural log, where we are to find the derivative. So here are some basic rule. We have 1 to 3 here. So if a function is given to you and there is log there, that is, if we are having natural log of f of x and the f of x is raised to power of any function, again it may be ordinary number or a function, so just simply bring the number down here, that is, multiply the power here, multiply by natural log of the function, that is ln f of x raised to power of n. Here if you want n, multiply by natural log of f of x. So just normal rule from log when we're having log a raised to power of x, it will be equals to what? It will be equals to x log of a. So if we are having natural log of f of x multiplied by f of g of x, that is two functions, so you just simply do what? Share the log for them here and put plus between them, that is f of x log f of x plus natural log of g of x. So if we are having two functions which are dividing each other and they are in front and they are multiplied by log here together, they are with log here, so just simply what? Share it by what? By introducing minus to them. So they are just like logarithmic function where we are having here we are having log a b is equals to log a plus log b. So the same thing here, we're having log just from our common law that we know, just we're having log a divided by b, the same thing as log a minus log b. So this is just the part one. Just try to grab this log here. So I will try to solve some 1 to 4 questions here today. So this is the part one of the video, which we are to deal with this small exercise. So we have what? Y equals to what? Y equals to a raised to power of x, and we have to find the y dx. So the first thing is that introduce what? Log to both sides. That means we have ln, that is natural log y equals to what? Natural log of a raised to power of x. So use the first log here, since a is the function, a raised to power of x is the function, and we're having the natural log here, so that means x will come down, so we have ln y equals to x ln a. So that means we find what? And now differentiate all. So we have what? This implicit differentiation. Check my video on implicit differentiation. Whenever you differentiate, you have what? Whenever you differentiate y, you have what? The y dx. That means ln y will be what? 1 over y, the y dx equal to what? Equals to what? This is a constant. Ln a is a constant. Then differentiate with respect to x with what? Will be ln a, that is x raised to power of 1 minus 1 will be 0. X raised to power of 0 is 1, multiplied by this will be this. So now multiply through by y, so that you have your dy dx. So when you multiply 3 by y, you multiply this by y too. So we have dy dx equals to what? Y into y equals to natural log of a, which is your y here. Initially y is what? A raised to power of x. That means we have what? A raised to power of x ln a, natural log of what? Of a, and that is your final answer. That is, you have a raised to power of x ln a, and that is your final answer for the first question. We have the second question here. We have when y is equals to x raised to power of 2x. So just try to introduce ln to both sides too, as you did here too. So as we've done here, just introduce what? Log to both sides. That means you are having what? That means you have ln y equal to what? Ln x raised to power of 2x. So since ln is here, this will do what? Come down. That means we have what? Ln y, that is natural log of y, equals to what? 2x natural log of x. So differentiate, we have what? 1 over y, the y, the x, that is y prime equals to what? Now differentiate by using what? Product rule here. Let's first drop this, differentiate g of x, we have 1 over x, then plus, we drop this, now we differentiate this, we have 2 in x. So here this we reduce this, so we have dy dx, so multiply through by y, we have y to bracket of this, we have 2, since this is x has cancelled x here, 2 times 1 we have 2, then plus what? 2 ln 2 natural log of x. So you can factor out 2 here, we go 2y to bracket of what? To bracket of 1 plus 2 plus natural log of x, since you have factored out 2 here, so you can simply use substitute for the y. The y is what? X raised to the power of 2x, so 2x raised to the power of 2x, now 1 plus ln x. So final answer for that. So we have I have my third one here, that is I'm having y equals to 2 x raised to the power of x. So here be careful, we have what? We have constant and we have a function that is raised to power function. That means this is also a function, this is also a function. So introduce ln, we have what? Ln y is equal to ln 2x raised to the power of x. So here you share the length for them, since they are both having the length, so you have natural log of y equals to what? Share the log here, share the log, yes, ln 2 plus natural log of x raised to the power of x. So we use what? We use the function here, we use this one here. So now we differentiate, we have 1 over y dy dx equals to what? Equals to what? Equals to, this is the constant, this ln 2 is the constant, that means 0. Then you differentiate what? That means this will firstly come down, so this will firstly come down, we have x ln x. So we have 1 over y, now we are differentiating, now we differentiate y dx, y dx, y this x is equal to this constant. Now differentiate this one, since we filter this link to this has come down, so we differentiate this. Now we have what? Drop this, differentiate this, now plus drop ln x and differentiate x, we have 1 multiplied by ln x, we have this, so this will cancel this, so we multiply through by y, we have dy dx equal to y to bracket, this is 0 already, so this will be what? 1 then plus what? Ln x. So you substitute back for your y, so your dy dx will now be what? Now you use your initial y, 2x raised to the power of x, that means 2x raised to the power of x bracket of 1 plus ln x, and that's your final answer for that. So we have the last one here, we have the last one, which is number 4. We have y equals to what? Equals to 3x raised to the power of 4x what? Plus 1. So we introduce ln again, equals to ln 3 x to the power of 4x plus 1. So since you've introduced ln, what you did here, that ln we share what? Share this, we have ln y equals to what? Ln 3 plus ln x raised to the power of 4x plus 1. So that means your ln y is equal to what? Ln, that is natural log of 3, then plus all this will come down as the first law for 4x plus 1 ln natural log of what? Natural log of x. So now differentiate, we have 1 over y dy dx. Whenever you differentiate your y, do what? You put dy dx here equals to what? This will be what? This natural log of 3 is 0, so plus this, drop this first, we have what? X plus y, then differentiate this, we have 1 over x, then plus drop this, then x, and then differentiate this, we have 4. So that means we have 4x plus 1 all over x, then plus 1, that is this, plus 4 ln x. So you don't multiply through by your y, that means you are having, since this is 1 over y dy dx. When you multiply through by y, the y will cancel out here, so this will have what? This will multiply by y2. So one that means we have the y dx equals to what? Your y is what? Your y is this, so if you substitute for y, we have 3 to the power 4 x plus 1. I just bring this y here, so we have 4x plus 1 over x, then plus 1 plus 4 ln x. So that's the final answer for this. So try to have a look and have a nice day. This is how to just simplify for natural logs when you're having log. So just try to follow some the basic rules here and try to follow the step I use in solving them. So try to drop your comments, so you find what, try to drop your comment in other parts you want us to treat. So have a nice day and thank you for watching. Thank you very much.